Hello, this video is going to take you through the steps of creating a ladder logic program using Studio 5000. So the first thing I want to do is to run RS links so that we can verify that the computer is connected to the PLC. Okay, and you'll get a pop-up screen here. And I'm actually going to reconfigure it from scratch so that you know how to do that. So you go to Configure Drivers. We're going to stop and delete that one and take you through the current steps of going to Ethernet IP driver, adding new, OK to this, and you'll see that there are two IP addresses here. One that starts with 10, that's the college network address, and the other one that starts with 192. It's connected using a USB to Ethernet adapter, and it's what connects the computer to the PLC and to an HMI. So select the one that starts with 192, click Apply, and OK. And then close this window, and you'll notice that now you can see that the PLC, which is right here, these are all the modules of the PLC. Module 0 is the controller, 1 is the digital I/O, 2 is the analog I/O, and the others are for temperature and counters. So once you know that that's working, just minimize this window. And then the next step is to open up the program, the Studio 5000 program. I know it's on the desktop, but we'll just show you how to do it here if it's not on your computer. So click on that. We're going to do a new project. And the controller that we're using is in a series called 5370 controller. And it's a Compact Logix embedded system controller. And the model that we are actually using is this one right here, the 1769 L24ER QB FC1B. Make sure that you select that. Give it a name. Don't put any spaces in the name. And I'm just going to call it Demo 1A. Okay, and then click Next, and just verify that you have revision 29 here, and then click Finish. And now it's going to start to execute the Studio 5000 program. And this is the program that we're going to use to create the ladder logic. And in our case, we're not going to use the digital I/O, but I'll show you how you could use it. Okay, so go to main program, main routine. But before we go any further, one of the things that you have to make sure is this path box here that says none right now. Click on this. This is really a way to search for things connected to the network. And keep clicking until you get to the controller, which is slot 0, and you can see the name there, L24ER. Once you've done that, make sure that you select Set Project Path. And then you can close this, and you'll notice here that once you've done that, you've got the path up in this box here. It's important to do that. If you don't, you won't be able to download. So my next step is I'm going to add a couple of contacts, and I'm just going to start with one, and I'm going to show you how you would do it with the hardware, but we're not, because we're doing it remotely with an HMI. So if you were to do it with the hardware, you'd click on the question mark, and we'll give it a name. I'm going to call it Switch 1. But the name doesn't point to anything. So I'm going to right click on the name and say New Switch 1. And we're not going to make it a base tag. We're going to make it an alias tag because we want to have this name associated with the real hardware. And the real hardware is that local 1 input data, and I'm going to tie it to bit 0 of the 16 bits. Once you've done that, you see alias local 1, switch 1, and then click on create. And you'll be doing the same thing over here. New tag. You can do it this way too, and we'll say light 1. And it's not going to be a base tag for this example of connecting to the hardware. And it's going to be local 1 output data, and we're going to use bit 0 as well. And then create. Okay, now we can't run this because we're doing, at least I'm doing it remotely, so I can't manipulate the hardware switch and see the light come on. But we'll be able to tell actually if the switch is closed remotely by clicking download. And this just takes a few seconds, and downloading is where we transfer the program that's stored on the computer to the PLC. And it's connecting to the PLC over the Ethernet connection. We have a small switch and Ethernet connection to the PLC and to the router. Okay, and so I know that switch is not closed, but there is another switch on bit 1 which is normally closed. So let's change the properties of this, and we're going to change this to bit 1 because I know it's normally closed. Click apply, OK, and I'll download it again. Now we're not in the lab, but if we had a camera in the lab and we could see what was happening on this PLC, light 1 will probably come on because switch 1 is a normally closed, or data 1 is a normally closed switch. So we'll see if this light does come on. I expect it will. Okay, and it did. Okay, just as expected, because this switch is closed and the light comes on. But I'm going to go through an example where we're using the simulator eventually. So I'm going to start off by deleting these two instructions again. I call these instructions. And I'm going to put an examine if closed, a second examine if closed, and an output energized at the output. Notice these little green dots, when they come on, it tells you that it's valid connection. I'm going to add another rung with this instruction. I'm going to add a branch, and in that branch I'm going to put 2 more instructions and 1 more output. I like to do all of the instructions first and the names second. So I'm going to put switch 1. I'm going to put a second switch. Now I'm going to have to, one of the little problems that we have here, and maybe I should change the name, is because it's still holding the name from the previous instruction I did. So I'm going to actually cut that, put a new one in here, in front of here. And I'm actually going to call this switch A, because I know that name wasn't used before. Switch B. And this is going to be called out A. Oops, spell it right. Out A. Out B for this output. And I'm going to call this switch C and switch D. And there we go, we have all of our program. Now the red X's and the red lines tell you that there's an error in the program. And I can click on this button here, which checks for errors. Okay, and it's telling me that there's many undefined tags. So what we have to do is define them. And defining them is telling them, the software, what data type these are. So if I go to switch A, say new switch A, I'm just telling that it's a base tag and the data type is Boolean. Boolean is where the data is either a 0 or 1, true or false, 0 or 24 volts. So that one's fixed. This one is next. Base Boolean, create. Same thing here. Make sure it's base Boolean, create. And you see that line goes blue, telling you that everything is okay. And it's pretty quick eventually when you do this. Okay, and if I go back up here and check for errors, no problem. Great, we're kind of ready to test out the program. So this is going to be a logical ANDing operation where this has to be true, and this one is this true or this true. These are the line numbers. If I want to add a comment, I can add a comment by clicking on Edit Run Comment. And I'm just going to type in the word Michelle. That's good enough. And, I will put my last name in there. And it's June 17th, 2020. It's always a good idea to put your name and the date on that first rung. Click a question mark. If you have to put any other comments, it's just add rung comment. And this, I'll say or operation. Okay, and then the green check mark to move on. So everything is okay. And this is our ladder logic. And the tags that I created are going to be in this area here. And it even includes the ones that I initially created, switch 1 and light 1. They're not being used in this program. And this is where you can edit the tags, or you can even monitor them. If you wanted to change a tag value, you can actually type it in right here. Very useful. The controller tags are actually the hardware tags. That's like the local 1 input, local 1 output. These two are for analog I/O. And you can break them down into their individual bits as well. Okay, and I'm going to go online now. Go back to the program. I'm going to go online and download this program. Download means to take the program that's stored on the PC and transfer it to the PLC. So we actually have to do 2 steps. We have to download and then run. And I'm always looking in this window here to see if any red lines pop up. They tell you that there are errors. There doesn't seem to be. There's no errors and no warnings. Errors will not compile the program. Warnings will, but you should still read what the warnings are. And verify that these 3 squares are green. The top, run mode, controller OK, and I/O OK. And so what you can do here, when these are base tags, I can actually click on the instruction and say toggle bit. So you see switch 1 went green, and that indicates that it's a logic 1 or a high. And if I go to the tags and look at switch A, you can see that it's a 1 in that position. And I can do the same thing for switch B, toggle it. And since it's an AND operation, all inputs have to be true. That causes out A to go true. This one, only one of them has to be true. Any input true causes the output to be true. So I could turn that off by toggling it or using Control T. Either one will work. And even if they're both on, the output will still be true. Only if they're all off. So I'm going to make them all off. And well, I'll leave it on. And that way I can go into the tags and just verify that switch A, B, C, and D are all on. Okay, very useful for troubleshooting. So again, just some reminders. Make sure that you're in run mode. Controller is okay. And these are the controller or hardware tags. Your tags should be here under local tags because they're tied to this program and this routine. And this is called a ladder logic routine. The comments were done by clicking and edit run comment. Make sure you're checking for errors using this little verify routine check mark. Okay, then the RS links. Make sure that you see all of the modules here. Know your IP address. This is actually the IP address for the for the Panel View Plus. And you can even check the address of your PC by clicking on this box, Network and Internet Connections, and change your adapter options. And this is the Ethernet adapter for the college network. If you go to details, you'll see that it's 10 dot something. And this is the Ethernet adapter for the PLC. If you go to the details, you'll see that that IP address is 123. And they're on the same network. Okay, so everything seems to be okay. I can close this down. I can minimize this. The program did everything I wanted. And it's just important to remember the names that we're going to be using for that program. Switch A, B, C, and D, and out A and out B. Okay, that's the end of this section here. Hello, the next step is to create the actual HMI. And you do that using special software. It's called FactoryTalk View Studio. So you click on that. And this is also a program made by Rockwell. And we're going to open a new FactoryTalk, and it's actually called Machine Edition. So to do that, we've got to give the application a name. I'm going to call it Demo 1. Okay, once we've done that, the other thing that's important to do is to specify the HMI that we're going to use. And the one that we have in the lab is actually this one right here. It's a 7-inch standard 640 by 480 pixels, Trying to get that word. Here we go. And you also have to select that it's a standard version. Once you've got all that information, click on Create. And this is a part that takes about 30 seconds. So you want to wait the whole amount of time. And over on the left panel here, it's going to create the Explorer window. The Explorer window allows you to configure many different settings for the HMI. It's very much like the Explorer window in the PLC software. And this takes a little bit of time, and what we're eventually going to do is, first of all, configure the communications so that the PLC can speak with the variables that we're going to set up in this program. Okay, so the HMI communicates with the PLC. So it seems like this is stabilized. So wait till it does. Wait till it stops flashing. Go to Communications, Communications Setup. It's going to open up another window. Create a new configuration, then click on the Finish button. This window opens up, and we're going to do Add. And we're going to create a shortcut. And the shortcut is, instead of using the lengthy name with the IP address, it's just going to be a few characters. Easier to remember as well. So I'm just going to put Station 1 because that's what I'm at. And then I want to open up the PLC addressing to go to the actual PLC, which for us is this 192.168.1.30. One of the things to check that's very helpful is that down here at the bottom it says press apply button to assign selected path. Because if you don't put it on the correct line, you won't get that message. Okay, so you got to make sure you're on the right line. So press apply, and here's the apply button. Click on that, click yes, and there's another button that you have to click on. It's copy from design to runtime, and this is if you're going to program the actual HMI, but I want to do it in all cases. And then finally, when you're done all of that, important step, I often miss this step, but it's to click the OK button to save the changes and notify the RS Links program. And then this window closes. The next step will be to create a new display. So I'm going to click on Display and New. Okay, it gives you this blank display. And one of the things I want to have on this display is there is a special shutdown button. If I can find it quickly, I'll add it. Yeah, right here. So I'm going to add the shutdown button, put it right there, and you can even label it as shutdown. And this is very important if you're going to actually copy this information to the actual HMI. If you don't have that, there's no way to shut it down. The other thing that's very important here is I'm going to right click on the display, go to Settings, and change the update rate to 0.1. Then click Apply. And you'll see that that message says that this window needs to be shut down before the updates are actually applied. So what I'm going to do is come up here and do File, and then Save As. And I'm going to save it as Demo Display. Okay, and that's the display name. So you should see that there's a new tab here indicating that. What I'm going to do next is add 4 switches, and these are called maintain push buttons. And what they do is when you press it, it goes low, press it again, it goes high. Every time you press it, it changes states. So I'm going to put one here. Oops. Hopefully I got the right one. And I'm going to connect it to the variable, and that you have to do by going to Tags. I'm going to connect it to the variable for switch A. Now when you get to this tag browser window, especially for the very first time, you must press the refresh all folders. That's a very important step. And then click on, this was the shortcut, click on the plus to expand the shortcut, and they're online tags, so click on online, and they're in the main program. So click on main program, and here are the tags, switch A, B, C, and D, and out A and out B. Don't be concerned if you see more tags, as long as we have the tags that we used in the actual hardware. And they have to match up the names. If they're not the same name as in the program, things will not work as expected. So the first one I'm going to add here is switch A. So I click on this tags panel. Oops, I already did that. So switch A, double click, you see it appear here, then apply and OK. And we're going to put a second one and just underneath, and maybe a third one. We'll put them all there, and then we'll put the tags. Might speed things up. The other thing is we'll want to turn off the audio on each one, and we're going to put the correct address for each one. I'm going to go back up here, turn off the audio. We've already put the correct address there, and I did make a mistake there. That should have been the switch A. Not sure why I did that, but let's fix it up. Apply and OK. Same thing here, connections, and this is going to be switch B. And we want to turn off the audio. I think that's in general. And then switch C. Connections, tags, switch C, apply and OK. And same thing here. This will be for switch D. Apply and OK. So we've done all those steps. The next step is we're going to put two lights representing the outputs. And all I'm going to do is actually put, if I hover over this, it'll indicate that it's a rounded rectangle. So I'll put a big one here. Leave it like that for now. And another one just down here. So this is going to be out A on the top and out B in the bottom. And what we're going to do here is change the way they behave using something called animation. So if I right click on here and go to animation, I want to change the color depending on the data. And this is going to be out A. So I will find that here. And what it means is it's going to be red when it's a low and green when it's a 1. And then click apply and close. And the same thing here, but it's going to be for out B, and you actually have to right click, go to animation, color, tags, and then out B and apply. So I should have everything set up. So let's try to have the two panes, one of the program and one of the HMI on the window at the same time. Sometimes this can be a little bit tricky, but I think we've got it here. So we'll just try to move this over to the left, this over here, because I want to see the whole program. And if sometimes all you have to do is drag this window and make it a little bit smaller. You'll figure it out eventually. It's not too difficult. So now we have the entire program here. And now we have to run the HMI. And yeah, again, we'll eventually get it. Okay, I think that'll do. So the HMI is stopped right now. This is the run button. So click on that button, highlight this again, and switch B is already closed, but to make it's hard to tell because you can't, there's no indication here, but you can change it. There's ways of changing that. But if I click on that button, let's change this window so we can see everything. I'm going to click on the A button, and it turns on the A instruction. This is examine and close, so that goes true. This one goes true, causes the output to come on. And this one goes true and causes the output to come on because it's an OR. Okay, and I can turn them off one at a time. And the bottom two have to both go off. Okay, and if I want to check, well, I can see over here the program is doing what it should be doing, and I can even go into the tags to see the state of the tags. So switch A will change to a 1, B changes to a 1, and you also see that out A changes to a 1, and then both of these have to be turned on for that output to change. Switch D. That's a little odd, but let's check it. Oh, sorry, that I was wondering why this was high, but it's up here. These two have to be on. So if I turn any of these off, or both of these off, that causes out B to go off, and either of these two being off is going to cause out A to be off. So it's following the logic, and we'll just double check it in the program. I'm going to turn off B. So A and B must be on, or C or D have to be on to get the output to change. And there's the output again. One more time just to go through it. So A and B both must be on, and then C or D will change this output to a true. Only if they're both off will that go red. Okay, now there's a few, since I've got a little bit more time here, if you wanted to add your name or title, you click on text and you can just type on the screen. I'm going to put in my name and date. Okay, so that triggers that correctly. And then the other thing, remember we couldn't tell the state of these switches where they were true or false. Well, you can change the properties. So if I go to the properties and states, it should tell me somewhere is that state 0 and state 1, I can change the colors of those states or put a caption. So state 0, I'll put off, and state 1, I'll put on. And you can actually change the color of the text, the color of the background. There's many things that you can change. Make sure you click apply and OK. So now that when I run this, that's on, that's off. So it's a little bit easier to tell the state of the switches. And I can even do the same thing for these outputs here. I think you can. I'll just double check on that. Animation, color. No, there is no place to put text there, but there are different ways to highlight that. And then close that, try running it again. Okay, so everything seems to work as expected. That switch is off, this switch is off. Only when they're both on will that light come on. Okay, hopefully this helps you to understand how the HMI works on the PLCs in Lab CA219 at Algonquin. Thank you.